Hey everyone, welcome to Skill 10 video. So we're going to go over how to write a linear function for a problem and then use it to solve it. We've done a skill like this before, but in this skill, every single time it's going to be a linear equation in slope-intercept form. So we're always going to have slope and then our y-intercept. We're also now always going to be writing it in function notation, which we've learned in our previous skills. Okay, so first let's take a look at the structure of what all of these equations are going to look like, and then we'll practice writing them. So the first important part is our rate of change. We're going to have this in every single problem. It's going to be called different things, but for these real life problems, it's our speed, our rate. Usually when you see per or each, you could think of it as slope. That's going to be the value that's multiplied by x. So if you make $15 per hour, maybe it costs 15 cents per stamp, but this 15 represents that cost or the amount for each thing that x represents. Okay, the next thing is our initial amount. Sometimes it's going to be 0, sometimes it's going to be a number like this, but it's whatever we start with. If we start with 0 money, it's going to be 0. If I start with $50 in my account, it's going to be 50. Maybe the shipping fee is $4.50, so that's like that constant amount that doesn't change. This is your y-intercept or your initial amount. The last part that it's important is our function name, as I like to call it, but that's just this piece right here. It used to be y, now we call it f of x. You could say g of m, h of x. It's our output, it's our y. This is just our start of our function. Remember, we don't do any operations with this. We don't do f times x. This is just read as f of x. It's saying this is the function, okay? So let's try with the first example. And this is about Homelander. And he opens a bank account with $480. He deposits 50 each month. Deposit, remember, means to put money into the account. Write a function that shows the amount in Homelander's account after m months. So notice we're doing something general first. I don't know how long he's saving for, so we're just going to write a function that tells us how much is in his account at any given time. Okay, so I'm going to, since they gave us m months, I know my m is kind of like the x that was here. So after m months, I don't know how long that is. Then we need to find our rate of change or slope, whatever you want to think of that as. It's the amount that you multiply by m. So we need to know if we go for m months, well, how much am I adding every m month? That's 50. So 50 is going to go here. And the last thing I need to write is my initial amount. I can write it first or I can write it last. It really doesn't matter. But our initial amount is $480. So we're going to add $480. So what this tells me is Homelander, no matter what, is going to have $480 in his account. Then after each month, we're going to add another $50. That's what this represents. And then just to make this a function, we're going to say f of m equals. So it's saying the function is this right here. I'm going to write it in a different way as well. I'm going to write the same equation, 50m plus 480, and then in just like a different color, I'm going to write the name of this or what this gives us. So whatever amount I input for m, this is going to give me the money in his account. So maybe I input 1, that's after 1 month. Maybe I input 12 months, like a year. Whatever I get when I solve this is going to give me the money in his account. Okay, so let's use this to find out after how many months Homelander will have $1,030 in his account. So I need to think about, does this amount go in for m, the number of months, or does this go in for the money that's in his account? Think to yourself, and then I'll tell you in just a moment. All right, so I'm going to write my function. And if you guessed the second option that I gave you, you are correct. So we're actually going to replace this right here with the money in his account, because that's what we know. So we're going to replace this, and we're going to write 1,030 equals just like that. And so what we're going to figure out is what it asked. After how many months will Homelander have this amount in his bank account? So we're going to find out what M has to equal to make this true. So let's solve for M. I'll do it in my other color. We're going to subtract 480 from both sides of the equation. Okay, so I've got 1030 minus 480. That gives me 550 equals 50M. And then our last step is to divide by 50. Okay, so I get M equals 11. And remember, we were solving for months, so this is 11 months. That means it takes 11 months for Homelander to get to $1,030 in his account. All right, so that's going one direction with these equations. The next problem, we're going to go in the other. This one is a little bit easier. I actually started with the harder direction. So let's start to go on this problem. It says, if Howie runs 5 miles this week and then runs 2 miles every week thereafter, write a function to represent how many miles Howie has run after Y weeks. And then it says, how many miles has he run after 8 weeks? Okay, so let's write the general formula first, and then we're going to solve the problem. So it says Y weeks. So that means my variable here is Y. I can do F of Y, I can do G of Y. It doesn't really matter. I'm just going to keep it consistent. So I'm going to say F of, and usually we don't use Y as our independent, so we're going to change that. I'm going to say after W weeks. So we're going to say F of W. That's a little better. Okay, and we need to think about what the initial amount is and what our rate of change or our slope is, our rate, if you will. So Howie runs 5 miles this week and then 2 miles every week thereafter. So the only week he runs 5 miles is this one, the current week. So that's going to be our initial amount, 5 plus. And then he runs 2 miles every week after that. So every week that passes, we're going to add another 2 miles. So we've got the initial amount here, and we've got the rate with our variable. Notice this looks just like the first equation. It's just I wrote the initial amount first this time. Doesn't matter because we're just adding them. I just switched the order. Okay, so here I've got my function. This is the first part of the problem. Then I'm going to use it to answer the question, how many miles has he run after 8 weeks? So this time I've been given how many weeks. Remember, that's W. So that means wherever I see a W, I'm going to input 8. So I'm going to rewrite my function, but everywhere there was a W, I'm now going to put 8. Okay. So F of 8 equals, this is going to be the amount of miles he runs total. Remember, this is just telling me what I'm doing with my function. This is going to give me the output when I input 8. So F of 8 equals, and I'm just going to solve this right here. So remember, you need to do multiplication first, 2 times 8, so that's 5 plus 16, and then we're going to add those. F of 8 equals, and 5 plus 16 is going to give me 21. And we were talking about miles. Okay, so after 8 weeks, Howie runs 21 miles. Okay, so here's 2 really good examples. If you need more practice, remember, if you're in my class, I have posted some practice with solutions. Go ahead and get started on that. Thanks so much for watching, guys.